In the Translational Simple Harmonic Motion Lab, you are asked to take data of an oscillating system and then fit a line through that. And the equation you're given to fit is x equals x max sine omega t plus phi plus x naught. So xm is the amplitude of the wave, omega is the angular frequency, phi is a phase angle, and x naught is an offset. So let's see what all of these things mean. So x max is the amplitude. So let me go to my wave, and this value is twice the amplitude. So x max is this. That is x sub m. So looking at this value, let's see, this is 0.1, 0.2, 0.3, 0.4, 0.5. So this value is actually less than 0.2. And then when we divide that by 2 to get x max, we get it to be less than 0.1. So I guesstimated that it's about 0.07. So that's where I got my x max. So x equals 0.07 roughly. Then I have sine, and I have to figure out the omega t. So omega is the angular frequency, and it's 2 pi divided by period. Now, period is the amount of time it takes for the pattern to repeat itself. So one way of figuring it out is I'm going to go from here to there, so that's one pattern. And my axis is in seconds, so this is a little bit less than 1 second. Then I'm going to say that it's about 0.8 seconds. So omega is 2 pi over 0.8, and that gives me 7.85 radians per second. So that's why in my equation I have 7.85 times t. Now a more accurate way of figuring out the period is by counting the numbers of periods here and seeing how long it takes for that number of periods. So let's start here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. So for 12.5 periods, it took 10 seconds. Then one period is about 10 divided by 12.5 seconds. So that's a little more accurate. Again, we're just trying to make estimates here, so it don't have to be very precise, but my wave is pretty good. Then for the phase angle, you can plug in various numbers for this. I got about 1 degree here, so I'm more off here than I am over there, so I'm happy enough with the 1 over there. But like I said, plug in different numbers and see what your phase angle would be. The offset, x naught, so I have this value here. What that means is that we're looking at where the equilibrium position of the wave is with respect to the 0 here. So I have about 1, 2, 3, roughly 4. So 0.4 meters is where my offset is. So then I will add 0.4 here and get my wave. So you see that doing some estimation and some calculations, you can figure out how to fit a sine wave. Now you'll also have to use log or pro and have log or pro fit a line. Then you'll see that fit is going to look a lot better than yours. But the point of doing this is so that you can learn to interpret the different quantities on a sine wave.